For the green fire reaction, I have some copper chloride, which I'm putting into a flask with water. I'm putting in a few scoops, but I'm using a plastic spoon instead of a metal one because copper chloride reacts with steel and puts copper onto it, which is not good. So right now I'm mixing it all together to create copper chloride solution and dissolve all the crystals. Putting in some balls of aluminum I made, and you can see it is immediately reacting. It's an exothermic reaction, so you can see all the condensation on the sides. I'm quickly lighting a splint. We don't want all the hydrogen to come out before we light it on fire. So usually the explosion goes out immediately, but this time it is still burning. It's getting the water very hot, so it's starting to boil, which isn't ideal. You could probably put in a bit less aluminum to prevent this from happening. So there are really three things going on here. A double replacement reaction, where the aluminum and the aluminum foil is switching with the copper and the copper chloride. There is a reaction between the aluminum and the water, making some aluminum oxide and also releasing hydrogen gas. Then that hydrogen is ignited, and the copper that was in the copper citrate those atoms become excited and it releases green light. And that's why it's green fire, not just a normal explosion. The reaction usually works multiple times, but this time I think that it might have gotten a bit too hot and the water might have started to boil off, and that steam probably put out the fires before they could ignite the hydrogen gas. It's difficult to see how large the explosion was at normal speed, but in slow motion it looked much more spectacular. So that's green fire. Thanks for watching.